I'm Matt Lear, the Senior Director for the Navy and Marine Corps Software Solutions Portfolio for General Dynamics Information Technology, and I'm pleased that you guys could all join us today. This morning's session is particularly compelling to me because it's discussing digital solutions that are accelerating digital modernization for our customers. In the course of building enterprise-scale products, it is critical to drive agility and visualization at every stage, not just in development. In today's discussion, you'll hear two examples of this. First is the Overmatch Software Armory, and the second is the digital engineering environment, also known as digital threads and navigable relationships. Without further ado, let me welcome to the stage our today's featured speakers. First, we're going to have Dr. Jeff Millard, who's our Overmatch Software Armory subject matter expert. And second, we're going to have Mr. Mike Nash, who's the chief engineer for the digital engineering environment. Gentlemen.
All right, welcome everyone. Hopefully you can hear me well enough. Yes, no? Okay. We're going to talk today about the Overmatch Software Armory. Before we do that, I just want to kind of shout out, there's a couple other people in the audience supporting me. That is Todd Hunter and Jeff Dill. There's also an excellent engineering team behind all of this. They're not here, they're working, that's what they have to do. But we've been at this a couple of years now. We've made some really excellent progress. It's had some good adoption throughout the Department of the Navy. So on to the next slide. Let me see. Allegedly, there's a clicker. Wow, it worked. Okay. This is, don't get close to the speakers. This is a short talk, short agenda. Overview of the OSA. So spoiler alert, it is a CI/CD pipeline that exists within the context of an entire Navy DevSecOps pipeline. So we're going to go through some of what OSA actually is, the tools and capabilities it provides. And we're going to kind of place it in the overall pipeline, how this works and where it fits in. And part of that answer is going to be, this is designed for delivery to both shore locations, sometimes cloud locations, but is very much focused on the tactical edge. By that I mean CANES, the shipboard networks on the large ships, the submarines, and things like that. Next slide, please. So why? The real answer is speed to capability, right? This is the thing that is critically important to us. The speed to capability here is going to be enabled by a couple of things. One of them is pipeline automation, right? We're trying to shift security and operations to the left to make elements of that present in the development environment. For security, this is a lot of basically code scanning, testing, quality metrics, vulnerability analysis. Fix it while it's in dev. Don't fix it while you're trying to deploy. For the operational platform, what we're trying to create here also is a higher fidelity version of the platform environment. So it is not a replica, it's not a digital twin, it is nothing close. But it contains an awful lot of the enterprise services and important pieces that applications would use in development and take advantage of those enterprise services when they are finally deployed to a platform. This is a shared multi-tenant environment, right? One of the value propositions of this is it is not a simple thing to build these things. It is not a simple thing to maintain them. We shouldn't put the burden on every mission owner to roll their own, to make their own DevSecOps pipeline and connect it to the rest of the DevSecOps process. So we are providing that platform. We onboard customers. We help them get started in this DevSecOps journey with particular focus on the continuous integration, continuous deployment, delivery. I'm going to be real careful in my choice of words there, and you'll understand why later. We're providing this basically as a service for mission applications in particular, but any application that needs to streamline and automate their process, incorporate security, and look at an operationally relevant platform. We are driven by modern architecture, mostly microservices, and that's not because microservices is a cool buzzword and it looks good on your resume, although it is, and it is, or does. A lot of microservices has to do with some of the challenges we face on deploying to tactical edge. We cannot dump, large virtual machines on ships because we don't have the bandwidth. I come from originally supporting the Canes and ACS program, and not only the environment they work in, the DDIL environment, denied, disconnected, intermittent, latent, they just don't have that much bandwidth. And they have to share it for a whole lot of things. I won't give any numbers, but I have way more bandwidth to my house than an aircraft carrier has. And that's at the pier, okay? So these things have to be small. We also have to get into the modern business of delivering incremental updates, not big bang updates, and that microservices is an enabler of that. It's not the only way. Not everything has to be microservices. Some things never make sense to be microservices, but from a deployment standpoint, it's smaller, it's easier, it's faster, and one of the things that makes it faster is the processes that you can use for incremental updates can really help speed things like and enable things like continuous authorization to operate. Manage complexity. Microservices are complex. We want to extract away the complexity of running that platform and let the people who develop mission applications focus on developing mission applications. It's enough of a lift to containerize them. We don't need to make their job harder to make them run to the underlying platform. Next slide. All right. We're starting to get into what it really is here, and let me tell you a couple other things that exist in this environment. One, GDIT has implemented a SkyDesk virtual desktop interface. This was absolutely prescient. We did this before COVID, and it turned out to be a huge enabler of people to be able to use a virtual desktop infrastructure to securely access the network and securely access the OSA. So that has been key. It's been very successful, and that is ongoing. Subject matter expert engineering support. When you want help, I actually run the group that does that, and now the group that does OSA. This is simply an easy way to procure some number of hours to assist you with things in your journey to microservices and in your journey to cloud and in your journey to OSA. We also run the help desk. So those are the things. Now back to OSA. So OSA runs in the cloud. It is currently on IL45. Which if you're not familiar with impact levels, because we just talk about them all day, so I forget who knows and doesn't know. That's basically sensitive unclassified information at IL4 and national security system information at IL5, okay? IL6, you might guess is secret. We just are bringing that capability online with OSA. That's been around since 2021. We're in the process of onboarding people into that. So, but from an infrastructure standpoint, this runs on cloud. It is on AWS, it is on Azure. We provide a lot of the platform services, but the ones of most interest to a lot of our mission application developers is containers, right? And so we provide TAS or ACS, if you're not familiar with the acronyms. You can think of that as the system, the enterprise systems, that's Agile Core Services or Tactical Application Services. Those are the things that provide the container operation platform, the runtimes, the nodes, the brokers, all that other stuff, right? That is provided by Canes as an enterprise service. We provide that on OSA as an enterprise service. We do our best to maintain parity with what is being deployed to the fleet now and to maintain some form of parity for the next version so people who have a longer deployment timeline can also see that environment and don't build to something that's not going to be the platform by the time they get there. In our environment, coding, building, securing, testing, and creating those artifacts that are going to get you accepted by the platform, both for an ATO reason and for certification reasons. That's key stuff that are the outputs of this program. And the processes that are involved, obviously we have the continuous integration, continuous delivery, and this all feeds to both platform integration testing. If you're familiar with that world, application integration and system integration testing has partially moved to the cloud. In a case of something like Canes, hey, that's going to end up on a rack. There's no choice. You're not going to run a cloud on a ship. So we try to provide something that is, at least from a software and a virtualization perspective, very similar to what they're going to see in an integration test. And the historical past has been, and I'm sorry, I'm just chronically cynical, the historical past has been that an application would show up and it would be the first time they saw a Canes. They would encounter the security settings. It would break everything. They would go away, reschedule to come back. And that was kind of the cadence of integration testing. We're trying to move that left. We're trying to make sure that there's some interoperability that's been demonstrated before trying to go to a deployed system, right? So that's a shift left of ops. Next slide, please. DevSecOps. This, a couple things that might make it easier. The color coding at the bottom actually matches the pieces up at the top, all right? So that makes it easier. And then I did two things to hack the usual DevOps infinity, which must be like, continuous employment guarantee that it never stops. The OSA tools part is definitely in the planning stage, and the caveat there, this is not big R requirements from Congress flowing down. This is to the point where you've taken specific mission objectives and you're decomposing them into software development, right? People go off, they code. This has a build pipeline in it, okay? And if that is not a sensible term to you, you might know that software usually is assembled in some way, compiled in some way, and deployed, for example, in a container in some way, right? There are orchestration tools that handle all of the steps in that. We provide one which is Jenkins. Doesn't matter that it's Jenkins, just know that it's an orchestrator. And actually in OSA, it's deployed as a container. So if you come in as a program and you're like, I want to set up a pipeline, I want it to do the following things. I want to do a C# application, I want to do whatever it is I want to do. We don't look at you with one tilted eyebrow. We say, great, you got your own Jenkins container. We will show you, we've got some documentation on how you could configure this to be absolutely specific to your program. We'll also let you bring your own tools. If you have some particular tests you want to run, fine, BYOT. So the pipeline is actually fairly configurable and fairly flexible with the antithetical goal of also making it fairly easy and abstracting that complexity away from you. But it is a very flexible platform in terms of what you can do in the OSA part of it. The two tweaks to this. I split test, and we'll see this in a minute, and that is because there's a lot of testing that's going on in the OSA environment, and that testing is very code-centric. It is code quality, it is vulnerability analysis, static code analysis, dynamic code analysis, all those kinds of things where we can improve the security and the quality of these codes, of this code, right? When it passes all of that, and goes onto the platform staging environment, there are a number of other tests that they are going to run. Those tests are much more centric to the operability of the software on that platform, and usually results in some form of certification that this software is good to go to be deployed on a tactical network or on a shore network. The other place I split it, deploy, right? I have very carefully tried to stop myself from saying deploy every time I said CI/CD, and that is because we do not push things to ships. You don't remotely go, and if you worked at a hospital, you don't just remotely reboot the emergency room computers just because you have a patch to push, right? Everything we push ends up in a repository for the ship or other network to consume on their time frame, on their terms, right? So the actual deployment is totally owned by the platform, okay? And notice platform staging and platform operations is not the same people. The people who build Canes don't jump on the ship and go on the mission with them. That is signed over, that network is owned by that ship. So there is actually a bit of a disconnect, but it's a necessary disconnect. You know, Canes cannot manage 200 different networks remotely. It's physically impossible. Next slide, please. All right, I like this because it reminds me that I'm already old, and some of you are probably getting old too, and you can't possibly read any of this. But I wanted to get a lot of the things up there. The other reason to keep it small is there will be no holy wars over which tool we chose and why didn't we choose this and all of that other kind of stuff, right? We're doing what we can do, the best we can do it. And I've shown a couple of things here, touching again. This is in the cloud. You can access it either with Skydesk or by other methods. That is pretty much limited to CAC enabled, limited to Navy. There are steps to go through, but you can get in here. We have the usual suite of planning tools. coding tools, essentially, by that I mean in repositories. A ton of testing things and the ability to bring your own, and test frameworks like TAF exist in this environment. As this cycle repeats and you create a product that you think is good enough to be promoted to a platform staging environment, it gets pushed to a repository and then consumed for an integration test. We don't control that. We just try to integrate as well as possible with it. The artifacts generally are going to be, from a software standpoint, they're going to be container images, right? And they should be immutable. They should run everywhere in the same way. If they don't, they get kicked back. When they go through the integration testing and staging on the platform, we should have everything in hand for RMF approval, especially for incremental changes. There's certainly a concept that at the beginning, the entirety of an application might need to be authorized by itself. But after that, increments in continuous ATO tend to be accepted by the platform owner, who issues essentially a memorandum for the record that they accept any residual risk associated with deployment of this upgrade. Okay? So that's the process. It goes down to one of many possible endpoints in terms of the network it operates on. That's where it fits, and I am thankfully done. Next slide. Can't read this either probably, but these are the contact people. There's me, there's Jeff Dill, there's Todd Hunter. Feel free to reach out to us if you would like to get any more information. And hand it over.
All right. Still on? Check. Yep. Thank you, Jeff. Very exciting. Oh yeah, we're good on the slides here. We are going to have a little bit of opportunity for Q&A at the end after I get through my slides here. So my name is Mike Nash. I'm Chief Engineer with GDIT on our digital engineering environment technology. And I'm going to start off my presentation. First, everyone can hear me okay? Good. I'm going to start off my presentation with a little audience engagement. So the first question I like to ask is, who has ever updated a spreadsheet with information only to find that it was out of date, and they updated information in a spreadsheet and needed to get a new version before they enter that information? Anybody? Yep. Maybe for this audience assembled, a better use case would be, is that too loud? Sorry. Better use case would be, who has been managing a software development lifecycle and wants to understand the status of their releases, but doesn't want to have to be a GitLab operator, or who has other people in the organization who may not be a GitLab operator, or who maybe just want to know, how much is this going to cost me, or when is it going to be released? What's my schedule? These are the types of questions we're going to answer. So I'm going to give my presentation with a little bit of a DevSecOps flavor, since I think that's the audience assembled here. But this is a broad capability that's domain agnostic, and I hope I get that point across. Next slide, please. All right, so I'll start off with more of a classic sales pitch. So what is digital engineering, and why do we care? What's its value? The punchline at the bottom is one I like to start with: connecting data that has never been connected before. So we want to bring everybody in an organization, an enterprise, to the digital engineering table. That's why the example I used is, if you're performing a management function into a software release cycle, you want to be part of this digital engineering. Systems engineers for a long time had been very good at connecting their data and orchestrating processes and doing data integrations. And I could rattle off a number of tool-specific integrations that have been performed. But often these fall within the systems engineering ecosystem, or even in the software development ecosystem, and haven't been able to be extracted out to the enterprise. So what we want to give you with digital engineering is, I'll start off with the top bullet there, a customizable visualization that's user-centric. I'm a user, and I want a single pane of glass to be able to filter all the data in my organization, query it for what's of use to me, and create use cases around that interest. I want to be able to access that data in a service-based environment, and I want those services to be automatically generated so that when data in my organization or my enterprise changes, I get notified of those changes, or my tool or application is notified of those changes. So both users and systems get that update automatically. Sounds great, right? How do we do it? Next slide, please. So let me give you the OV1, if you will, of our digital engineering environment. I'll start off, let me see if this pointer works. Hopefully you can see that. I'll start off here at the top of this slide. So we start in an organization, or let me start by saying, what is a digital engineering environment? So at its core, if I could simplify it, it's a technical data package that's hosted in a cloud. So a technical data package could be a number of different applications, tools, data, anything that you use to conduct your engineering processes. So what we do when we examine an enterprise and convert it to a digital engineering enterprise is we start by taking the applications that need to go into a DevSecOps pipeline. That's why it's a good segue from Jeff's presentation. To the greatest extent possible, we want to harden and secure those containers and utilize infrastructure as code to precisely define our applications in code. And the reason we do that is because we host them, we are cloud agnostic here with respect to digital engineering, host them on any number of our cloud providers, and then release them into the digital engineering environment. So that's here in the middle. So once we get an application in the digital engineering environment, we call it an ASOT. That may be a new acronym for you. It's an authoritative source of truth. So what an organization does once it has an application in the digital engineering enterprise is it assigns truth to and provenance to data. So if my software releases are managed in GitLab, then my release management schedule, GitLab becomes my authoritative source of truth for my software. However, there may be other users or applications in the enterprise that want to become familiar with that software release cycle. And so these are the consumers around the ASOTs of that data. I've listed a couple functional roles in there to kind of get you familiar with what that could be. If I'm a user in the digital engineering environment, I want to be able to collaborate with other users. I want to be able to perform workflows. I want to do some of that automation that I talked about. Something that may be a very important interest is dashboarding and real-time reporting. So I want to have event management so that when something changes in one of those ASOTs, I'm alerted and I'm aware of it, and I can structure dashboards around it. And I want my entire environment to be model-based. So I want it to also connect to my systems engineering environment or my software environment so that this digital representation of what's happening is connected to the rest of the enterprise. The bottom piece right there is our technology that we use to do all this, and we call that navigable relationships and digital threads. So let's start by examining what is a digital thread. A digital thread at its core is a node-edge graph. It's entities and relationships that are connected together. So I can construct a digital thread, and I'll give a simple example. We're all familiar with kind of requirements verification process. So I may have a requirement that's hosted in a requirements management tool. Maybe I use Doors, maybe I have a Cameo model. Somewhere my requirements are hosted. But then I have a design tool to build that system. That design tool for physical systems could be something like in CAD. If it's a software system, that design could be in GitLab. And so now I want to connect that requirement to my design tool. But that information's in two different places. So I construct a digital thread to say, okay, I've got an entity from my requirements tool and I've got an entity of my design tool. Now I want to do that traceability, right? Classic example of requirements verification. What we want to do is make that requirements verification objective and digitally connected. So that, sure, we can do that one time, we can verify a requirement, but what happens if my requirement changes or I want to make changes in my system design? Now I want to make sure that owners and consumers of both sides of that equation are updated as information changes, so I don't have to redo that drill, and it's not subjective, it's digitally connected. I can bring that information in front of me and see it in real time. So model-based systems engineering, plus our concepts of digital thread with DevSecOps, gives me my digital engineering environment, the tagline there at the bottom. Okay, next slide, please. Okay, so that sounds like a lot of work. So where do I hop on this digital engineering journey? How do I get on? And the punchline is it's actually not quite as much work as you might think. there are on-ramps into this process anywhere you are in your digital engineering journey. A lot of organizations have a lot of information represented in models and in applications, but they just need to do this connectivity drill. So we start up here at the beginning of the journey with past approaches, sort of the dark ages of engineering with document-based approaches. A lot of this still persists today, especially in legacy worlds, where we have really lack of transparency, lack of version control. The classic example I started with on a spreadsheet version, that's really what I'm talking about, the dark ages of engineering. As we move forward, we get to the organization step. And really what I mean by organization is starting to add structure to your data. I think about this in terms of models, but even getting information like your requirements data into an application lifecycle management tool like Jira, now I have added structure to that information. Even getting my software development lifecycle into GitLab, I have added structure to that information. So it's not explicitly models at that point, although models certainly add that structure. Once I have that structure, I start to see some of the benefits. I start to be able to automate some of this integration that I talk about. I start to get some of this real-time event management notification. I start to see some of the benefits. I'm able to make better decisions as a result of this. So that ends up getting me things like leaner infrastructure, reduced cybersecurity risks. I'm going to walk you through an example, a DevSecOps example where we can see this. As I continue my journey into an ad modeling and SIM, now I become very powerful in my organization where I can start to do what-if analysis, parametric deep dives. So if I'm a network engineer, I want to be able to simulate changes into my network environment prior to me implementing them. And I want to be able to do that in a digitally connected way. So that's where we see at the bottom, the real future state, if we're going from the dark ages to the future state of the digital engineering world once we've got that modeling and SIM built in. Next slide, please. Okay, so here begins really the technical part of the presentation. So I'll dive into what is happening under the hood here. And I've created a diagram that's a general purpose representation of our core technology, what we call navigable relationships. So I'm going to describe this in general, and then I'm going to walk you through a particular usage of this with respect to DevSecOps. So at the core is what I've got labeled here is our transformation engine. This transformation engine contains a meta model. Don't let that term scare you. A meta model is just a model of a model. So this is an abstract layer that defines any type of information that could come from a broad range of applications in your digital engineering world. I've just put a couple of icons there to kind of get you thinking about what types of applications I could be referring to here. So I create this meta model as a very general purpose abstraction. This meta model defines things like types and relationships, very abstract level of data, but broad enough to be able to capture any type of example. The next concept I want to talk about is this here on the left, is our schema library. Again, schema, don't let that term scare you. Schema is just really a data model, and a data model of information. And I have the icon here to show you that that's actually a modeled representation. We use standards in our model. I'm talking here about OMG standards, object management group languages, UML, SysML, DODAF, UAF. You've heard of those types of things before. Our schemas are UML models, so those are just entity relationship diagrams, class diagrams of information. I'll give you an example. I use the requirement. So a requirement is an entity in my digital engineering environment. An attribute may be its text or its ID, something like that. It's actually quite simple when we model it that way about what a requirement is. So I have this generalized notion of what data is from my schema library. And now I start to pull information in and out of my digital engineering environment via this transformation engine. So you can think about schema as a very directed target of information. If I define, for example, a requirement in a schema, this transformation, and let me get into, the data services aspect of it. If I define requirement very precisely in my schema library, then my data services routine knows exactly what to look for when scanning my environment for a requirement. And so I've got all this schemas translated into a model-based data repository. That's a property graph database. We use Janus Graph in most of our examples. So now I can pull out and I can search for requirements over here in Jira, and I can get all of my requirements reposed in a model-based repository here. Now, if I need to extend that model-based representation out to another area in my digital engineering, another model of a requirement, I've got, and you see the bidirectional arrows here, I've got a way to pull information out from my digital engineering environment, in this case a requirement, back through the reverse path into my model. So now I don't need to stand up, I don't need to have staff that go build models of requirements when I already have my requirements in my environment. I can pull this information, extract it in a targeted way, and then automatically generate those requirements in other places. And so those requirements I've abstracted here, as they're called digital threads. Each time I do this targeted extraction of information back and forth, I'm extracting a digital thread of information. So I assemble all these threads, and I can stitch them together. So threads cross over other threads, and I start to weave this digital fabric of information together. Now, the final piece I'll mention here is up here at the top. I mentioned kind of the legacy domain. So maybe you've got all this information resident in documents already, and you say, well, I can't stand up this digital engineering environment. That would take a long time and a lot of staff to pull together, all these models of requirements or whatever it may be. So we've established some techniques just through some simple natural language processing, and again, with the injection of data models into that engine to say, okay, target me the requirements out of my documents. Requirements are very, typically have structure to them. So even in textual-based formats, I can go ahead and instantiate those models directly from this schema library, and we have examples of doing this for customers. So that's the environment. I didn't quite highlight all of these services here, but I'll hit on them briefly. So now I'm starting to talk about the assemblage of quite a bit of digital information here. I want to make sure that I have access control of it. And in fact, what we've seen is that we actually have more precise ability to restrict information to consumers now that we have modeled it in such a granular way. So now that we have this schema, I say, okay, this person has access to this element in the digital thread, but not this other element. So I can start to segment this information from my digital thread fabric to restrict information and for the purposes of security, whatever it may be. Event management here is another important piece. So I can't just do this one time and be done. I need to make sure this is a living technical data package. So what event management does is it registers interest in these digital threads. So now that I've established in my schema what a requirement is, if I'm interested in that requirement, interested when it changes, I have a very precise way to be notified of changes to that requirement, very schematically defined way. So that if I am operating another tool and that requirement changes, that event manager lets me know that that representation needs to be updated. Okay, next slide. So I'm going to walk through an example of this, a specific example using infrastructure as code and DevSecOps. So the example here is that I want to construct a Teamwork Cloud server in AWS. Actually, if you might click one more time back there might be some animation. There we go. Okay, thank you. So I want to construct out here a Teamwork Cloud server in my cloud. And I want to do so using infrastructure as code DevSecOps. So I'm a DevSecOps engineer. I can do that. I have the tools. I've got a GitLab console. I've got my Ansible and Packer tools. I create a YAML file for that representation of that server. I may give it I'll parameterize it with its correct EBS volume and EC2 type that I want, and then off we go. It hits the pipeline, and I've got a Teamwork Cloud server stood up in my cloud. So that's all what's happening over here on the right. That's all exactly what we want our DevSecOps process to do. But what about the rest of the digital engineering environment? They want to know about this Teamwork Cloud server too. So that's what we've got going over here on the left. So I may want a model of that Teamwork Cloud server so that I can connect it to a requirement When my requirement for more models that I need to add to Teamwork Cloud, I may need to expand that EBS volume. I want to change it to a different EC2 type. And my DevSecOps engineer may not know that's the requirement that's going to drive that change. That may be a systems engineer over here that's constructing models. So I've got a systems engineer over in the digital engineering environment who recognizes the need to expand the volume of that Teamwork Cloud server. So to start with, I've taken that representation and I've run my reverse path through this transformation engine, and I've automatically instantiated it for that systems engineer. So they didn't go through the process of capturing it from a spreadsheet to type it into a model. They're ensuring that it's accurate because it's automatically stood up from the description, from the declarative of the server itself. So they've got it in a model, and now they want to expand it. Again, I list the schema over here just for reference to say all this is possible because I've got a schematic description of what this server is. That systems engineer can update a value in their model. So they've updated just a parameter of their digital thread, and then they commit that model to their model repository, and boom, I've got an event management change going on in the environment. So I've recognized a change, I've registered interest in this server that's represented in model, and now I've got something new. I extract that information, I put it into my model-based data repository, and now my GitLab pipeline calls that API, updates my YAML file based on this new property, and sends it back to the pipeline. Now I've got a new Teamwork Cloud server with an expanded EBS volume that meets my need. So what I've done here in this example is I've walked through how I don't need to take my DevSecOps engineer and train that person on how to use this specific model. No, I let them continue to do their job. Vice versa, I don't have to take my systems engineer and make them understand what's going on in the DevSecOps pipeline. I let them each continue to do their job and not talk over each other, rather the data be updated real time as it's changing. So I've gained huge efficiencies here in how to operate my digital engineering environment by this targeted extraction, event management, real-time updating. Next slide. I'll just briefly hit on a couple other examples of how, that was example of DevSecOps. We've got a couple other kind of classic examples that may resonate with you in graphical format here. Now that you've kind of understood the concept, how do I apply that to other places? We get this question a lot on model-based RMF controls for continuous ATO management. Up here at the top, you may be familiar with how to do RMF, Risk Management Framework. Often we've got teams of cybersecurity analysts, the information security officers, information security managers, trying to capture all the information about what's happening in their environment, document-based process, not really a lot of confidence in the data that's coming out of that document-based process that my authorizing official is actually authorizing what is happening in here because it's been transcribed through a document-based process through subjective measures to get in front of that authorizing official. Well, as you can probably guess, with a digital engineering environment, we automate the extraction of information from our cloud-based environment so that we have models of what's happening there. And at any time, if we need to export a document-based representation of that information for an authorizing official, we can do that. Now we're not using our security team to write documentation. We're using our security team to secure a cloud. And that's what they're best at, not writing documentation. So again, we've got efficiencies in our organization as a result here. And also a lot more confidence that our cloud is actually more secure, and what our documents that are describing our cloud are accurate with what's happening within the cloud. Next slide. Requirements verification, another classic example. We've probably all done this. We've got requirements models somewhere in our organization or enterprise. Here I've represented use of Cameo to model requirements, and we've got an ALM tool. I've used Jira here. And a lot of us have done this drill. I've done it, where we sit in a group and in a spreadsheet, and we take information and said, okay, I've got a Jira feature here that satisfies this requirement. Okay, check that box. That one's good. All right. Oh wait, we just had a change out there in Jira. Update that spreadsheet. Get a new export of Jira. All right, bring it to the next meeting. Let's make sure this goes on and on and on. Very inefficient. So what we've done here, you may beat me to the punchline, but using Schema and this transformation engine, we extract requirements of interest to us, both in our model repository. We extract ALM data out of our Jira software, and we utilize a common repository. We actually have a kind of palette-based whiteboard tool where we can visualize these digital threads in a tool-agnostic manner. And we just simply draw lines, traceability lines from our requirements model to our ALM tool to say this satisfies this. We're always up to date. We always have objective information. And once we do that, that traceability, once we draw that there, that information is passed back to my requirements model. It's passed forward into my ALM tool to say this requirement is now satisfied. Next slide. Last use case is what I call model-driven testing. So another classic example is I build software because I have some requirement to do it. And then I have people that test that software to make sure that it works. However, the interpretation of that tester they can verify that that software passes its unit tests, but does that software actually do what the requirement said it was supposed to do? That's a different question. And so right now we had the situation where we had software testers that were trying to read requirements to make sure they understand the operational concept of how the software was supposed to work. This proved difficult and again subjective in that type of analysis. So what we did is we took a modeled description of that requirement and extracted that information as a test specification, and then put that test specification in the same test automation tool that our testers were performing unit tests from. So now our tester was in their test automation tool. We use Zephyr for Jira. They were in their test automation tool, and they had a test specification that was pulled from their model in the same place that they were running their unit tests. So they could give a pass-fail result directly from the software and feed that back to our requirements model to say, our tester verified according to this requirement. All right, next slide. Okay, so that concludes my presentation. Hopefully that gets you excited about digital engineering. I will be available at the GDIT booth to answer any questions. I've got a lot of these built as demonstrations if you'd like to dive into any more detail. And I think at this point I'll open up for some Q&A. I'm not sure where we're at on time, but if there's any questions from the audience, I can take them from Jeff or myself, or we can meet you up here and have some further discussions. The question was, he heard how we extracted legacy information from documents, but how do we extract legacy information from systems, from operating systems? So I'll use an example of a network. So I've got an operating network, and I want to extract that information. So by the same manner that I represent, I went through that example as a server, as a declarative, using infrastructure as code, I can represent networks in the same kind of declarative format. So in the same way that I have an operating server, I could have an operating network, or I could have an operating platform, weapon system, whatever it is. As long as I can come up with a declarative, think of these as like JSON, XML, even text, CSV, any way to add structure to that information, I have the ability to pull that information from an operational environment into my digital engineering environment. So not just documents, good point, can be any operational system. Thanks. Yep. Any other questions? Yeah, did you want to use mic or just? Okay.
I think there's some push DoD software factories to collaborate. I don't know if you consider OSA Information Factory, but how are you working with the software factories?
We're kind of not. I mean, the Air Force has Project One. There are other software factories out there. Yeah. The question was, how does OSA operate with other software factories within the DoD, right? And somewhat apologetically, somewhat not. We focused on Department of Navy. The Air Force has their own. The point of connection typically tends to be a collection of hardened base containers, right? So we all start with a good starting point, and that helps programs that are joint programs. We'll give you a mic. There's a mic here too.
I can just yell really loud. So I'm curious, with the risk assessment that you were doing, are you seeing that folding into things like threat modeling and coming into that space, and how are your software teams using that?
Yeah, that's a good question. I think there's some natural extensions to a lot of these use cases after you have that data in an organized fashion. So I get the question a lot is, so how do I add some AI or ML to that use case to be, so that it can sense changes in the environment rather than being reactive to those changes. So I think it kind of ties into your question. The ability to merely to accurately model your system and expose its risks and vulnerabilities, I think gets us a lot closer to being able to understand how our adversaries understand our systems as well. And I think it will give us a better opportunity to protect it. So I don't know if that's a great answer to your question, but the end result of doing this drill has been a much faster time to mitigate the open vulnerabilities than prior to implementing this digital engineering environment. Do you have anything on that one, or you're good? I hope that answered your question a little bit. Yeah. Do you want the mic, or?
So there's building software, having it ready like once you deploy it, monitoring that deployment to make sure that it's healthy and actually performing to the level that you want. How do you kind of bridge that gap between developing over an environment that it's being deployed to and getting that feedback from developers and communities?
Yeah, good question. So the question is how we've got deployed software, and how do we get that? How do we get the user validation that software is doing what it's supposed to do back to the developer? So sort of like validation and verification, of deployments. So I think the reverse. So a key concept in the digital engineering environment that I went through is kind of forward and reverse paths through the environment. So what you're talking about is kind of a reverse path where I've got something out there, but I want to feed that information back to elsewhere in my environment. So what I would imagine in that case is being able to come up with with a declarative for that user to perform that validation, and then being able to move that information, let's say, not in a document-based way, but in an environment, in a tool where they register, this is, where they're checking to say this is doing what it's supposed to do, this is not doing what it's supposed to do, so that if I'm a developer, I bring up my palette of digital threads that say this is what my software does, and then I connect in a digital fashion to the validation result that I got from my user, so that that my developer, and again using that kind of event management, could be notified of a bad validation result when gathered from the environment that it's deployed in. Yeah. Good question.
This is going to be a much less elegant description because it's more kind of practical. There is an effort within OSA to essentially connect the ship trouble ticket system, which happens to run on Remedy, I think, with the development ticketing system, which runs on Jira. So there's a small amount of technical work that is done there, but is absolutely a difficult problem to solve because of the inaccessibility of a ship's platform to feed a large quantity of data back to developers. So there's the attempt to connect it from a ticketing system perspective, right? The enterprise services on board ship also provide the logging capabilities and those kinds of things. There is some of that, but anything that involves an offboarding of a large amount of data, it's not routine, right? So it tends to be episodic. When it's necessary, we do it. That's not digital engineering in the sense that it has been described. That would be a fantastic thing to have that. The other direction that people have approached that is what I'd call the Apollo 13. Hey, something really bad is going on. We have a digital twin of this, and we have duct tape, and they have duct tape. That kind of approach to it as well. When you don't have the ability to share data and models and things like that at present.
I think Jeff's point about the ticketing system would be a great way to gather that information back. I think thanks for filling that in. But yeah, being able to be a developer and actually see some of the tickets that come in related to the software that you develop would be a powerful way to improve your software development process through digital engineering. Yeah.